Next couple podcasts, next 5 podcasts are just more and more and more practice making sinusoidal functions. Okay, so here we go. Let's go back to an ocean question again. This is, of course, dealing with depth. This guy has a maximum depth of 22 meters, but check this out. It's at 1 o'clock in the morning. That's going to mean something a little bit later on. It's going to put a little bit of a wrench into our plans. Not much, but you'll see. The minimum depth, again, is 12, and that's at 6.3 hours later. So why don't we draw this? First thing that I want you to draw here is I want you to draw that this has a maximum. So there's our maximum that's going to be at 22 meters, right? Our minimum is going to be at 12 meters down here. So it's actually a pretty deep part of this port. All right, now, what's interesting is you know and I know that the maximum is now, if you think about this as a nice little timeline, because that's usually how we describe this is in terms of time. What gave you that idea? I don't know. Okay. But it says its maximum is at 1 o'clock. That's 1 o'clock right there in the morning. So that means it starts before, at 0 time, at midnight, it's still climbing. It's still climbing to get to that maximum height. Ooh, that's interesting. So finally it gets to that maximum height, and then it starts on the decline like this, and then goes back up to that maximum height there. How long does it take to get from here, maximum, down to 12? Well, that's 6.3 hours later. That's important. So what happens here, it gets down to this point, from its maximum at 1 o'clock to this point, which is, guess what? 6.3 hours later. Ah, look at that. So that's going to be at 7.3 o'clock. I know that sounds weird, doesn't it? But it's at 7.3 hours. Because remember, you start at 0, 1 hour in, it hits its maximum. 6.3 hours later, it hits its minimum. But I got a question for you. Look at what A asks. A asks, what's the period of this? Well, wait a second. If you think about this, ladies and gentlemen, look at this. Check it out. You only went half of the cycle. So you still have to do the other half, going all the way up. Cosine cup. You betcha. So this is 6.3 hours. This takes another 6.3 hours for a total of, 12.6 hours. And there you go, sports fans. There's your period. Nice. Nice. So as soon as you get the period, you know and I know, you can get the b value, 2 pi over the period, which is 12.6. And I would just leave it just like that. That's good enough for me. Okay? All right. So what else can you get out of this? Can you figure out what the A value is and what the D value is? Of course, because you've got a max and you've got a minimum. So your A value, of course, remember, small stick means, you're going to subtract 22 minus 12 over 2. 22 minus 12 is 10 over 2. This works out to be 5. Okay, and our D value, longer stick, which means 22 plus 12 over 2, which of course 22 plus 12 is 34 over 2, which works out to be 17. Now, why do I say long stick? Remember, long, those 2 lengths, right? Okay, yeah. So, but you know that the D is right in the middle. It's your average. So add the 2 numbers together, divide by 2. You're done. Okay, so that means this guy's right here is at 17. There's your D value. Can we figure out an equation? You bet you we can, because look, that's what it asks us. Write a positive cosine equation. Don't forget about this shift, though. That becomes really, really important. Okay, so let's draw it out. Remember, this is always as a function of time. So height is a function of time. So we're not going to use x's, we're going to use t's. What's our A value? Our A value is 5. Okay. Cosine, our period, which is really gross looking. Look at that, 2 pi over 12.6. That's just, blech. So I'm going to put a big bracket around that. Okay. Small bracket around that. And then, of course, now I've got my x. Don't forget you shifted 1 hour to the right. So that's a -1. Oh, can't be an x, has to be a t, right? Almost lost it there. Oh, and then our big bracket, because all of that is under the cosine. Okay, plus now our d value, which is our d value is going to be 17, right? Wow, that's not that tough, is it? Uh-huh. But now look at this question. Now look at this question. It says, write me the simplest positive sign equation for the sinusoidal function. Exactly the same thing here now, but I want it as a sine. Okay, well, which things are the same? Well, the amplitude is going to be the same. The period is going to be the same. The d is going to be the same. The only thing that you're going to change is this to a sine, and unfortunately, you got to work that one out. That's the problem. That's the issue right there. So the issue that comes up here, folks, is how much do you shift this by? Well, think about this. This guy has to come down this way and go here. So its smallest sine function will start behind the 0 o'clock at midnight. It starts here, goes around, and then comes back up to here and stops here. My question is, what is that point? Okay, so how do we do this? Well, it's actually kind of simple to figure it out. Because what you got to remember is if you put your entire D line down, you'll notice that this intersects perfectly between here and here. You know and I know that one cycle from here to here is 6.3. So that's halfway, isn't it? Halfway, which works out to be 6.3 divided by 2, which works out to be 3.15. That's the halfway point here. So guess what? If that's 3.15 from here to here, right? Oh, but is it? No, it's not. The reason why is it's not from there to there. It's from here because there's your maximum height was at 1 o'clock. So from here to here is 3.15. Oh my gotcha, this is getting confusing. Now, so what? My question is what is this point right there? So if that's 3.15, remember to go from this top back to here is also 3.15, is it not? But yeah, don't forget, you started at 1 o'clock in the morning. So how much did you actually shift back? Take 1 off to get you back to the 0 line, and this little section here then is actually minus 2.15 because you took off the 1 o'clock because your maximum is at 1. So the shift is left, this is left by 2.15. There's your shift. That's your C value, right? So your C value is negative 2.15. So the rest is easy now. So height, T, equals to 5. Now it's a sine function, sine, same period. So put it in there of 2 pi over 12.6. How beautiful. Your time now is shifted left, so this becomes t plus 2.15, right? And then this is plus 17. Everything else is the same. The only thing that's different is the shift where you started from. Now, how do you prove that? Well, simple. Throw it into your calculator. Look, I've got it here in my calculator already. I am in radians. I set up my windows to be exactly what I have on my graph from 0 to 24 hours. Okay, going up by scale of 1 from my minimum value of 12 meters deep to my maximum value of 22. I put the cosine graph in there. Boom. And it's going to look an awful lot like this. Now, the big issue then, folks, is this. You got to put the sine function in there, right? You got to put this guy, and it better draw it right over top. It has to draw it right over top. So let's see if we're actually correct. Okay, y equals 2. Go down to y2. That's the same. 5, but now this is a sine. The bracket, okay, just like we did before, we're going to put in our fraction. Look how this is exactly the same as what you have above. 2 second pi over 12.6. Okay, move that over. Bracket. Now this is going to be your t instead of minus 1. That's going to be your t plus 2.15. Don't forget your second bracket, plus 17, and that still works out to be the same. You should have a blue line, and over top of it, a red line. Ready? Graph me. And there's my red line going right over top. So you know that those two equations are exactly alike. Whew, that's a lot of work. Okay, so back to the question then. Look what the question D says and E says. It says estimate the depth of the water at 2:15 p.m. Don't forget, this is a 24-hour clock. So you go up to 12 o'clock plus at 2:15 would be 13 for 1 o'clock. Okay, that's 13. For 2 o'clock, it's got to be at 14. So 14 and 15. Okay, remember, you got to put that as a decimal. Well, you know, and I know that a decimal for 15 minutes is a quarter of an hour. Okay, beautiful. There you go. 14.25. So I'm going to just use the calculator. I know this is a value, so I'm going to throw it in there. I'm going to go second calc, find me that value at 14.25 o'clock. Boom. I got 21.7 meters. That's my depth. And it says, oh, doesn't even say to what decimal place. So what did I get? 21.7 meters. Let's put it down as 21.7. That's beautiful right there. Okay. Now look at the last question that we have here. The last question says estimate one of the times where the water is 15 meters deep. Again, remember your formula was h of t. So that's your height. That's what this is. So unfortunately, you got to go into your calculator here. I'm going to go to the y equals 2. Let's get rid of one of these guys. Let's get rid of the sine one. And let's just make this 15. There's my y2. Graph it again. There's my beautiful cosine one. Here comes my 15. I want to find the first time that it's actually going to be at 15 meters. Looks like an intersect to me. Boom. Enter. Oh, too far. Let's try this again. Second calc. Intersect. Let's move it closer. You got to get closer. There, because then it'll find that point. Enter, enter, enter. Look at this. The time at 15 meters is at 4.97. What does 4.97 mean? 4.97 means 4 o'clock in the morning. That's 4 a.m. But remember, this is 0.97 of a minute, or of an hour, I should say. Well, okay, wait. I'm going to go over here. Then I go to this, right? I'm going to put my x equals 2 down. There's my 4.97. I know it's at 4 o'clock, so again, subtract the 4 o'clock off there. I've got now 0.975 of an hour, okay? Times it by 60. That'll give me my minutes. 58.5. So I'm actually at really close to 5 o'clock. This is 4:58.5, which if you ask me is 4:59. I'm almost at 5 o'clock in the morning. That's how you do this. Okay, stay tuned. We got more.